Welcome back to lecture number 4 of group theory. Okay, in our previous lecture we have seen some of the element of symmetry and symmetry operation, but today we will see two element of symmetry, that is, first is center of inversion. Now before starting with center of inversion, I will give you a small definition of center of inversion by drawing a particular diagram. Okay, so see, okay, if this is any particular molecule, okay, if I take, now consider this as a molecule, okay, we'll take a general example in order to understand the concept in a brief. Okay, so if this is a molecule, this is the perfect square. Okay, if I take any point that may or may not contain any atom in a molecule, let us consider this as a point. Okay, if I'm considering this as a point, okay, and if I pass from this particular point, I travel towards the center of this molecule. Okay, so after passing to the center, and if I move forward to the same direction, and if I find an equivalent point which is at the equal distance from the distance between the center to this point and center to this point is same, then this point which is called as origin is also called as center of inversion. Okay, now let me explain you with the molecule. Let us consider a basic example of benzene. Okay, now this is a benzene molecule. Okay, see, if I consider any point, let me consider this hydrogen as this point. Okay, now if I'm passing it, if I'm moving towards the center, I reach here. I consider this as a particular distance, suppose m centimeter. Okay, and if I travel to this carbon and this hydrogen, so this distance is also m. Okay, this distance is also m. So basically this point is called as a center of inversion. You need not choose only these hydrogens. Okay, you can choose this point also. Okay, if you choose this point, you travel to center and then you again move to this point. Now this point and this point are both the points are in equal distance from the center. Okay, and that is why it is called as center of inversion. Okay, now let me give you one more example of ethene molecule. Okay, ethene, where carbon-carbon double bond and there are 4 hydrogen atoms. Okay, if I consider this hydrogen, okay, this hydrogen, we move it to the center which comes to the double bond center, and then again you move in the downward direction, you find again an H atom, hydrogen atom. So these hydrogens are inversion, or the center is called as center of inversion. Okay, you can consider this hydrogen also same, and if you consider this point also, if you consider, you reach the origin and you move further, you will find the same point. So what my conclusion after studying center of inversion is that hydrogen are a particular point in a molecule. Okay, if we travel towards the center, okay, and if I travel again towards the same direction, and if I get an equivalent point, that point which is at the origin, which is at the center, is called as center of inversion. Now the thumb rule says that to do operation of inversion. Okay, now you can do basic inversion operation to only those molecules which possesses that inversion, like for example benzene, ethene, or you can choose example of chloroform. Let me consider an example of chloroform. Now if I consider this chloroform, my first question is whether the center of inversion exists to this, and the answer is no. Now why the answer is no? Because if I consider this as a point, okay, chlorine. Now chloroform may we have Cl, 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 and this is an hydrogen atom. Okay, so if I consider this chlorine, then again I reach to this point. Okay, that is the center, and if I want to go again towards the same direction, I find one chlorine. But if I consider this as a point, hydrogen, Okay, if I go towards downward direction, I would not find, because all the atoms are chlorine here, none of them are hydrogen. So this molecule does not possesses any center of inversion. Okay, so the molecule which possesses center of inversion, you can consider benzene, you can consider ethene. Now I will give you one more example by considering maths into it. We'll consider this as a structure. Okay, now if suppose this is a hypothetical structure where I have numbered all the atoms as 1, 2, 3, 4, 5 and 6, and if I am giving an inversion operation, okay, if I am giving an inversion operation, the 1 will be inverted to 4th position and 4 atom will be inverted to 1 position. Okay, as you can see in this. Similarly to 3 and 6 also, the 3 will be inverted at this position, 6 will be inverted at 3 position. Here you can see that. And same with 2 and 5. So 2 will be inverted at this position, 5 will be inverted at this position, as you can see in this. Okay, so center of inversion is very simple to understand. It is very also easy to recognize at the same time. Okay, so you have to remember thumb rule. Thumb rule says that in order to do operation of inversion, you have to interchange the position. Knowing this, would be able to write a structure of any molecule after undergoing inversion symmetry. But you have to remember one more thing, that you can do only to those molecules which possess a center of inversion. Now let us have a comparison between Ci and C2, that is center of inversion, and C2 axis. C2, if you remember, we have seen in proper axis of symmetry. Okay, now I have taken the same molecule, that is ethene, where this is 2 carbon atom which is having a double bond, and there are 4 hydrogen atom. Okay, let me denote it with A, B, C and D. And if I am giving this molecule as inversion, because it possesses center of inversion, okay, because this is an hydrogen, if you travel at this position, you reach to the center, and to the equal distance you have another hydrogen molecule. So you possess a center, this molecule possesses a center of inversion. Okay, so if I do an inversion, what I will find, that A is inverted to D position and D is inverted to A position, as you can see here. And C is inverted to B position and B is inverted to C position, as you can see here. Now what if I give a molecule C2 axis of rotation, like this is a molecule, and if suppose this is a principal axis, okay, this is a principal axis, you will have to rotate the molecule in this format. Okay, you will get an indistinguishable structure. If I denote it with A, B, C and D, if I give a C2 axis, your A will be flipped at B position and B will be flipped at A position, as you can see here, and C will be flipped at D position and D will be flipped at C position, as you can see here. But by any chance, if I do not denote it with A, B, C and D, I will find the same structure, or the same structure, because all the atoms are hydrogen. So these two structure would be same if I am not denoting it with A, B, C, D, or if I am not labeling it with A, B, C and D. So in short, that inversion versus C2, I wanted to say you that if you denote it, that only you will come to recognize whether it is an inversion or whether it is C2 axis of symmetry. Okay, so this the major conclusion about the center of symmetry is point, or the origin, as we have seen in ethene molecule, we have seen in benzene molecule. As in fourth the lecture goes on, lecture progresses, we will see some complicated molecule exhibiting such type of symmetry. Now let us move on to improper axis of symmetry. Okay, now improper axis of rotation is denoted by Sn, where n is the number of order of rotation. Okay, now if you remember, we started with proper axis of rotation, and I have told you what is proper axis of rotation means. So now by the name itself, we can come to a tentative conclusion that improper axis, that means any axis, or it would not consist of a proper axis, that is in reality, that if any axis is present, that is imaginary only. Okay, so improper axis is that axis only, that it need not be a proper axis. Okay, so if you want to define improper axis of rotation, we would consider it with as operation, that is symmetry operation, one of the symmetry operation, okay, which consists of two operation symmetry. One is rotation and the other is reflection. Okay, now let me give you an example of methane. Okay, let me take an example of methane. Okay, we'll explain in this format. Okay, if you consider this as methane molecule, the black is the carbon atom, and all the red bonds is carbon and hydrogen, carbon and hydrogen, carbon and hydrogen. Okay, this is a methane molecule. Okay, now in this molecule, if you rotate it by 120 degree, okay, 120 degree, you will get an indistinguishable structure. You can rotate it with you can say that it consists of C3 axis, but if you are holding this molecule in this format, you will say it is C3 axis or C4 axis. But if I hold this molecule in this format, okay, can you see this? Okay, now if I'm holding it with this format, matlab the carbon is at the center and one hydrogen is here and the other hydrogen is here, and one hydrogen is pointing towards you and the other hydrogen is just behind this hydrogen. Okay, I'll hold it in this format. Okay, okay, I'll hold it in this format. Okay, now by any means, if I can pass a axis, okay, if I can pass an axis, see, this axis cannot be in reality it does not exist, but if it is an imaginary axis. Now why I am dividing? Because one hydrogen is here and other hydrogen is here. So if I could be able to divide this molecule into this format, like considering this as an axis, okay, one hydrogen is here and other hydrogen is here. If this is getting divided, if the axis is passes toward this also, so you can see this molecule which is having hydrogen at this side is also divided. So if you're dividing this upper hydrogen, you are dividing simultaneously the lower hydrogen. That means the molecule is easily divided, okay, by this axis. Okay, and if you could give a rotation by 90 degree, okay, now see this position, okay, notice this position, it is V shape. Now if I am rotating it, now the V shape in the upward direction is now no more a V shape, it is in the downward direction. So this is a distinguishable structure. Okay, this is a distinguishable structure because you can see this this V shape in the downward side, but initially it was in the above side. Okay, now if by any chance I can reflect this, or if by any chance I can pass a plane of symmetry perpendicular to this axis, okay, that is imaginary axis. If I'm passing through a plane of symmetry, okay, so अगर मैंने plane of symmetry pass किया, मतलब मैं reflection करना चाहती हूँ, I'm going to do reflection, and if it is reflected, so this hydrogen will reflect it at this position. Okay, this hydrogen will reflect at this position, upper position, and this hydrogen will reflect at this position. Okay, similarly this hydrogen will reflect at the downward direction and this hydrogen will reflect at the downward direction. And if you could imagine that it is the initial structure, the reflection would be in this format. So by giving one rotation and one reflection, you are getting a molecule which is indistinguishable in structure. Okay, I'll repeat one more time. If I'm holding this methane molecule in this format, we have hydrogen this side and this hydrogen is this side. And by any means, if I can insert or imagine a improper axis, or I can imagine an axis which can divide this V shape into two parts, and if it is dividing this also, this V shape into two parts, then the molecule can be in symmetry, right? So if I give a rotation, one rotation, like 90-degree rotation, okay, if I give 90-degree rotation, I get this as a structure. Okay, I get this as a structure where V shape is in the upward direction and now V shape is in sideways direction. Okay, and if I am passing a plane which is perpendicular to this axis, which was perpendicular, see, this is the axis which is perpendicular to this axis, this indicates that this hydrogen will show the reflection at the lower side. Okay, lower side, and this hydrogen will reflect in the upward direction. That means it would be in this format again. So this is the initial structure. So this indicates that one rotation and one reflection will lead to an improper axis of rotation. So the definition or the Sn can be written as Cn and sigma plane, which is perpendicular. How do I read this? Cn and sigma perpendicular. Okay, the example was methane. Okay, now let me consider S1. If I say S1 and N, as you know it is an order of rotation. So if we consider S1, S1 means you are given 360-degree rotation. Let us consider this molecule. Now suppose this is an atom. अगर मैंने इसे S1 दिया है तो it will rotate 360 degree and it will come back to its original position. See, we have given one rotation. Now we have to give reflection, and this is the plane which is passing through this axis, and if it is reflected, this molecule would come down. Okay, so you have not done anything, you have just reflected this molecule. So this means S1 is only reflection, or it is an operation of plane of symmetry. You can say this is sigma h. But in many books I have seen that it considered that sigma perpendicular, which I have written here, they consider it as h, but which is wrong, which is not justified, because Cn axis, or we are considering improper axis, which may contain a principal axis or which may not contain a principal axis. Okay, so stick to this only, sigma perpendicular. Don't consider it as h, but in this case it is h only, sigma h, and it is if the plane is perpendicular to this axis. Okay, so you will find a reflection. Upward direction में है तो वो lower direction में reflection आएगा. तो इसका मतलब क्या है कि the only plane or the operation involved is plane of symmetry. Correct? So S1 is only reflection, or it is an operation by plane of symmetry. Now let us consider S2. Okay, now S2 is quite interesting. S2 मतलब दो rotation दिया है, दो rotation in the sense 360 divided by 2 is 180 degree, मतलब 180 degree का rotation दिया है, and if it is 180 degree rotation, that means the molecule or the atom will reach at this point. And you have given one rotation, now you have to give reflection. Now this is the plane, and this molecule is now reflected at this position. Now if I see this molecule which was initially at this position, what I find that this is the center of origin, where from this point to this atom the distance is same, to this point to this atom the distance is same. That means these two distances are same. This indicates of the recent symmetry which we have learned, that is center of inversion. So S2 is nothing but inversion, or S2 is equal to Ci. Now what if S3 comes into picture? S3 matlab C3 axis with sigma perpendicular. S4 matlab S4 axis with that is C4 axis with sigma perpendicular. So this was all about element of symmetry. In our next lecture, we will see more about mathematical formation. May we have clubbed all this together. So this was all about the basics of your symmetry and symmetry element and symmetry operation. I hope you have got the clear idea about symmetry element and symmetry operation. Okay, so in our next lecture we would describe more about, or we would club everything in a mathematical form, because this group theory or this element of symmetry or symmetry elements, which was used in maths in very previously. So before the chemist used to use it. So from the next lecture we will use more mathematical terms like set, subset, etc. So wait till then. Thank you so much.